different perfect squares. I shouldn't have to talk over you, so if somebody next to you is talking, can you just remind them quietly and politely? Okay, so we have 4, 9, 16. Let's talk about where those are coming from. So the 4 comes from doing what?
2 squared.
2, okay, 2 squared. Okay, the 9 comes from
3 squared.
3 squared. 16 is 4 squared.
25 is 5
So then the
squared.
next one will be 5 squared, which would be 25.
Then 36.
36. What's 7 squared?
Then 49.
49. 8 squared?
64.
9 squared?
81.
81. And 100, okay? And then it would keep going from there. Now, when you're checking perfect squares, you know when to stop because eventually the number is going to get larger than what you have underneath the root. So for 40, I know that I could stop at 36 because the next one is bigger. Okay, so we talked about how 4 goes in there, and we also said why we have to use the 4 and not 8 times 5 because we need the perfect square. So I can rewrite this as a product. So this would be the square root of 4 times the square root of 10. And the square root of 4 becomes 2. Can you take the square root of 10 and get a whole number?
No.
Nope, so that's why that stays inside. So when it says simplest radical form, you are going to have a radical, and you are not going to have a decimal. Okay, so when it says simplest radical form, what that means is you're going to have no decimals. Okay, and then your answer will either have a radical or, in some cases, it will be a whole number. Okay? All right, so then let's set up our next equation.
Again?
So
Wait, like stop.
Wait,
Well,
stop.
not.
You can stay, I'll check.
No, we gotta go.
Yeah, like, do it, go.
Okay, so you know how to do the next one?
Disregard that last alarm. That was a false alarm. Thank you.
What am I doing?
Shush.
I gotta say,
Guys, I need us to get focused. I know it's very exciting with the bell ringing, but we need to get through this. Okay, so the next thing we're going to do is set this up for part B. So again, the first thing that you want to identify is the hypotenuse. And you can find the hypotenuse because it is always across from the right angle. Okay, now in some cases your x might be on the side and you'll have to solve for that. And I am going to show you how to do that in a little bit. Okay, so when I set up my equation, you can think of it as x squared equals 8 squared plus 4 squared. So 64 plus 16, which is going to be 80. So then when I get here, I can take the square root. I'm always going to be taking the positive. Oops, sorry. Okay, and then again, I'm going to be looking for perfect squares. Now, there's a couple different ways you can do this. You can start with your list, and you can see, does 4 go into 80?
Yes.
Yes. Okay, so that's one way you could do it, and I'll show you that way. So you could think of it as 4 multiplied by what? 20. So then you'd have 2 times root 20. But is there a perfect square in 20? 4. So that would be 2 times the square root of 4 times the square root of 5. So you'd have to find the perfect squares more than once. And the square root of 4 is what? 2. So it's 2 times root 5, which would end up being 4 root 5. Now, another way you could do this is you could find the largest perfect square. So maybe when you divide, you notice when you do 80 divided by 4, you get 20. And when you do 80 divided by 4 equals 20, you can say, oh, I know that 20 has a perfect square in it. I'm going to keep going to see if I can find a bigger one. Okay, so 80 divided by 9, is that going to work?
No.
Nope. Okay, 80 divided by 16?
No.
Yeah, how many times does it go in there? 5 times. So you could also do, or we know that the square root of 80 is equal to the square root of 16 times the square root of 5. What's the square root of 16? 4. So then you get the same answer. Okay, and you can choose. You can do either way, where you're finding the smallest ones or where you're finding the biggest one. Okay. All right, so then the next thing we're going to do is we're going to talk about something that is called a Pythagorean triple. So when you have a set of 3 non-zero whole numbers, okay, so non-zero just means not 0, and then your whole numbers are like 1, 2, 3, etc. Such that a squared plus b squared equals c squared, that is called a Pythagorean triple. So none of these above would be a Pythagorean triple because is 2 root 10 a whole number? No, whole numbers are your counting numbers. Logan, Jay, pay attention up here, please. Okay, so whole numbers are like 1, 2, 3, 4, all the way to infinity. Okay, they cannot have radicals in them. So what we're going to do is we are going to find the missing side length, and then we have to tell if it forms a Pythagorean triple. So find the missing side length, and then tell if it's a Pythagorean triple. So if you don't have a whole number, then you know right away that you do not have a Pythagorean triple. Okay, so we're going to draw a right triangle.
Please pardon the interruption. The alarm may go off again. Please stay in place. It was tripped by accident, and they have to reset it, so it will probably go off one more time. Just stay in place. Thank you.
Okay, so here are our 2 triangles for A and B. So here we have 14, here we have 48. Notice that your triangles are not drawn to scale. Okay, so we can't just go on the look of them. So we can't just look at them and say, oh, that's the longest, that's the shortest. And here is our X, and here is our X. Okay, so we are going to set up the equations. I want you to set up just the first step for each one, for A and B. Okay, so I want you to write the Pythagorean theorem with the appropriate values plugged in for A, B, and C. So remember, your first step is to find what? The hypotenuse. Okay, so find the hypotenuse for each one. Okay, so Brianna, what's our hypotenuse for this one? Yep. So can you tell me what your equation was that you set up?
14 squared plus 48 squared equals x.
Awesome. Okay, so I'm going to write x squared equals 14 squared plus 48 squared. Okay, and Riley, what's 14 squared? I thought you already did.
I did, but I did them together.
Okay,
So
it's okay.
I just got the whole number.
Well, find 14 squared though.
Alright. 196.
Okay, good. And then Sam, will you find 48 squared for me?
2,304.
Good. 2,304. All right, so then we're going to add those together. When you add them together, you should get 2,500. And then we're going to take the square root of both sides. Okay, so x is going to equal the square root of 2,500. Do you guys know how to take the square root on your calculator? Okay, so then we're going to do the square root of 2,500, which you can find with your calculator. Or do you guys notice that you can break this down into two things? What? What and what? Isn't this just 25 times 100? Is that something that you notice when you look at it? Because you have the two zeros. So if you broke this up into root 25 times root 100, the square root of 25 is what? 5. The square root of 100 is 10. So then when you take the square root of 2,500, you get 50. Okay, so then you have to say if this forms a Pythagorean triple. Okay, so Jay, what do you think? Does this form a Pythagorean triple?
Yeah,
Okay, how do you know?
because all values are greater than 0.
It has to be more than that. Can anybody add?
And a squared plus b squared equals c squared.
Okay, good. One more thing, Taylor.
They're whole numbers.
They're all whole numbers, right? Okay, so yes, it's going to be a Pythagorean triple. Okay, and your Pythagorean triple would be 14, 48, 50. So this is the Pythagorean triple. So remember, every Pythagorean triple is going to have 3 non-zero whole numbers. Okay, so if I asked what your Pythagorean triple was, you would say 14, 48, 50. Okay, now Tanner, can you tell me the equation that you set up for B?
I did 4 squared plus x squared equals 1 squared.
Good. Okay, so your hypotenuse is 12, right? Okay, so then if you set up 12 squared equals 4 squared plus x squared. Okay, this is now my hypotenuse, which is why that has to be by itself. So I have 144 equals 16 plus x squared. So what I have to do now is I have to solve for x. So I have to get x by itself. So Chloe, what would I do first to get x by itself? That's what we're going to do second. So before you can square root it, see how you have the 16 added? You have to move that over. So how are you going to do that?
Subtract 16 from 144.
Yep, so you're going to subtract 16 from both sides. You get x squared equals, so if we do 144 minus 16, let's do 144 minus 10. What's 144 minus 10? 134, and then 134 minus 6 will be 128. Okay, so then what we have is x squared equals 128. So then we're going to take the square root. Is 128 a perfect square? No. How would you know that if you took the square root in your calculator? You get a decimal, right? It wouldn't be a whole number. Okay, so what we're going to do is we're going to write this in simplest radical form. So I'm just going to write not a whole number. Okay, so then we have to check for perfect squares. Yeah, so did 4 go in there? Yep. Do you guys want to find a bigger one, or do you want to do 4? Okay. Okay, so if we do 4, 128 divided by 4 is what? 32. So this would be 4 times root 32, which would give you 2 root 32. What is 32 breakdown? What's the perfect square in 32?
4 and 8.
4, you can do 4 and 8, or you can do
6.
not 6. Oh yeah. So you're thinking 36. 6 and 6.
Oh, yeah.
2 goes in there, but we wouldn't want to use 2 because is 2 a perfect square? No. So if 6 did go in there, you wouldn't want to use it just because it's not a perfect square. What is a perfect square in 32? 4. What else is a perfect square? 16. 16 times what? 2. That's what I would use. So 32 is 16 times 2. You could do the 4 again, but then you'd get 8, and you'd have to do the 4 again. Bless you. Okay, so this is 2 times, what's the square root of 16? 4. So 2 times 4 is 8. So this would be 8 root 2. Okay, so for this one, it would be no, because they are not all whole numbers. Okay, now it does say to find the missing side length, so you do have to find the missing side length. Okay, and then you either say yes, it forms the Pythagorean triple, or no, it does not. All right, and then we're going to flip it over. Okay, so the next thing we have is the converse of the Pythagorean theorem, which tells us that the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, and then we know that a triangle is a right triangle. So we're going to write that in our own words. What this is saying is if you know that a squared plus b squared equals c squared, then the triangle is a right triangle. And the reason why it's a converse is because for the Pythagorean theorem, you know that it's a right triangle. So if it's a right triangle, then a squared plus b squared equals c squared. For the converse, if you know that a squared plus b squared equals c squared, then you know it's a right triangle. So you would be given a squared plus b squared equals c squared. And then what you would know or what you would prove, the triangle is right. Okay, and then typically we would call this A, B, C. So triangle of A, B, C. Okay, and then the next thing we have is the Pythagorean inequalities theorem. So in triangle ABC, it says C is the length of the longest side. And then we have two different equations here. It says if C squared is greater than A squared plus B squared, then you have an obtuse triangle. But if C squared is less than A squared plus B squared, then you have an acute triangle. So we're going to just draw a visual representation of that. Okay, so here's A, B, C. Okay, so if you have that C squared, if that length is greater than A squared plus B squared, then you have an obtuse triangle. If they're equal, what kind of triangle is it?
Right.
A right triangle. Okay, so if it's greater than, it's obtuse. This is A, B, C. And then if C squared is less than A squared plus B squared, then it is acute. So the way that I'll always write this is I'll always do the C squared first. So I know if it's greater than, it's obtuse, and less than, it's acute. And it said the names of these triangles were ABC. So this is your ABC. This is your A, B, C. So we have to tell if the measures of the can be the side lengths of a triangle. And if so, we're going to classify the triangle as acute, obtuse, or right. So remember, if it's a triangle, the sum of the two smaller sides have to be what?
Less than. No, greater than.
Greater than the third side. Okay, so we learned about this the other day. So the sum of the two smallest lengths have to be greater than the third length. Okay, so this would be 12 is greater than 10. So yes, it's a triangle because the sum of the smaller sides is greater than the third side. Remember you guys did that the other day? Okay, so when I set this up, what I do is I do C squared. So I do C squared, and then I put a blank, A squared plus B squared. And then I fill in the blank with the appropriate symbol. So the way that they give these to you, they're always going to give you in the order A, B, C. So like for B, this is A, B, C. So your C squared is 10. So 10 squared blank, 5 squared plus 7 squared. So 10 squared is 100. 5 squared is 25, and then 7 squared is 49. If you add 25 and 49, you get 74. And I know that 100 is greater than 74. So because C squared is greater than A squared plus B squared, I know that the triangle is obtuse. Okay, if they were equal, it would be right. And if it was acute, it would be C squared is less than A squared plus B squared. Now again, the first thing that you want to do is make sure it's a triangle. So I'm going to take the two smaller sides, 8 and 5. I have to make sure that's greater than 17. Well, 8 plus 5 is 13. Is 13 bigger than 17? No. So then this is not a triangle. If it's not a triangle, then you don't have to go any further. If it is a triangle, then you have to figure out if it's greater than, which is obtuse, less than, which is acute, or equal to, which is what kind of triangle?
Right.
A right triangle. Okay, so you guys are going to do 5, 7, which is on page 352. Numbers 2, 3, 9 through 11, 13, 15, 16, 19 through 21, 30, 32, and 33. Okay, and then we will check your 5, 6, and 5, 7 homework tomorrow. Okay, I know that seems like a lot. It's really not. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have less than 15 problems.